So everybody have a good time at GORUCO? Since I know that they won't do it for themselves later, let's give the organizers a hand right now. Great job, great job. So I'm Evan Phoenix, and I'm going to be talking about Rubinius and what it is, and sort of where we are and why I think you should be using Rubinius. So the way that this is going to work is it's going to be sort of, it's the end of the day. You need to get that boat party vibe going, right? So we're going to do a little audience participation. So like if you want to chime in, if what I'm saying is confusing, whatever, don't just shout. Raise your hand at least, so that we don't have a just cacophony of voices going, "You sucks." So. But let's start with a question. Who here is unaware of what Rubinius is? Fuck yeah. Oh, one guy. You fail. You want to come up here and sit on stage and I can tell you about it just personally, or? Okay, all right. Okay. Actually, this works well. The 9 people that are around him, just tell them what it is, please. Thanks. So. 2011 has sort of been the year that Rubinius breaks through. I've been working on the project since 2006, and it's sort of been this slow burn, which, we've been careful and we've been working on the project, and we've had setbacks here and there, but we've been improving and improving and improving. And this year, I think finally for the first time, we've gotten to the point where we're hearing good things. That we're hearing, I hear from people, oh yeah, I'm running it on here and I'm using it for X, Y, and Z, sort of for the first time. So we've really reached that sort of critical mass. And so I'm going to talk a few things about how we got there and how you could help, and why I think that you should help build on that mass and use Rubinius also. So the first thing, I really wish I had my presenter display. The first thing is, why bother with Rubinius? We've got these other Ruby implementations. What's the big deal? The Rubinius is built off the idea that Rubyus can have it better. We don't have to be saddled with a runtime that we work around, that people say like, oh, well, X, Y, and Z doesn't work very well in Ruby, and they'll frame it like that. So don't use these really easy patterns. Use this very complicated thing. We can have it better. We can have our cake and eat it too. And that's what Rubinius is framed on. It is built on the idea that not so much a single release, but on a philosophy that everything, it's going to continually get better, that as we're building on a foundation that we've built ourselves, and every release gets better, every release gets more compatible, every release gets faster, and the limit for a lot of those things is sort of almost astronomical. I believe that we can hit great heights never seen before by dynamic languages inside Rubinius as we keep progressing. So improving over time. All right. So a big part of improving over time is obviously performance. That's sort of been the big thing that has held Rubinius back for a while. And we have really spent a lot of time in the last 2 years or so really improving performance. And the next thing that Rubinius brings to developers is tooling. And we're going to deal with both of these two things in my presentation. Tooling is things, how does Rubinius make the developer experience better, right? So as you're going to spend most of your time writing this code, and then it's going to be done, it's going to be running, it's going to be off somewhere else. So how does writing that code and making it good, what's that experience like? What tools can you be given so that you can write code that is easier to understand and runs better? So the next thing I'll talk about is where is Rubinius going in the next 6 months and in the next year, right? So we're looking to release Rubinius 2.0 sometime this year. And we've got a preview release of 2.0 that's coming out shortly. And in 2.0, we're going to release Ruby 1.9 support. So that's going to include the syntax and the new APIs and stuff like that. It's going to also include a whole bunch of new concurrency things. So in 2.0, we've actually broken apart everything the way that the VM works, and you can actually run fully concurrent Ruby code in the same way that, say, a Java developer runs fully concurrent Java code. You can use multiple cores, and you can actually have all of that power that other languages have as well. Yes, sir?
The 2.0 breaks the GIL?
So the 2.0 breaks the GIL. The answer is yes. So there's no, so that Ruby code can run fully concurrent. You can, like I said, use multiple cores. You can have multiple threads that do all of those things that you need to do inside one process. So which we can talk about this later at the end maybe. That poses new interesting challenges to the Ruby community because we haven't really had an implementation of Ruby that needed a lot of highly concurrent Ruby code previously. So JRuby has had this for a while, but for the most part, they've used the Java for a lot of the high concurrency parts. And this is one place where Rubinius is going to need that to be in Ruby. So we've got a lot of work to do for educating people and working on things ourselves and giving examples. So that's a big task, but we think it's going to be a really big thing. And the last one is Windows support. So, it's one of those things that is sort of it's just sort of necessary, right? We're not. Well, I mean, I'll be totally honest with you. I'm not super thrilled about doing it because I know that I'm not a big Windows programmer, and so it takes up more of our time. But it exists in an ecosystem that we can't really just ignore. If we want Rubinius to be big, if we want Ruby to grow and to take off more, we can't cut out that entire subset of programmers. We need to figure out how to bring them in with a loving bear hug, and this is sort of the idea. So. Now let's talk about some real-world Rubinius. That was all fluffy future stuff. I want to talk about what's going on right now. When programs stop being polite. So Rubinius right now, if you were to download it and use it, it will run slower than it should on some things. In fact, in some code, in some stacks and things, it will run slower than 1.8. And that's something that we're always fixing, that we're always improving, and that we're building off of. And a big point about doing that is we had to build a whole bunch of tools internally in order to improve that process, to make that process happen. But because we write all those tools and we put them into Rubinius, all those tools are available to you to use on your own code to make your own code better. And profiling is really the key to all of that. So let's go into a quick example of profiling. How do you use profiling inside Rubinius to make your code better? So it's going to be, so this is the science warning. I tried to keep it easy, but there are charts. So, if you need to change your underwear, go do it now. So, you got a problem. Some methods seem slow. Some action, some view, some controller, whatever it is, something. I should have put some grouping of code because it might not be. You don't know what it is. You know that some operation is slow. You're not sure what's going on, and you need to figure out how do I know that it's slow? Because it seems slow. Maybe it might not be. And then how do you improve it? Step one is always write a benchmark. So who in here has ever written a benchmark before? Oh, good. Great. So these slides are actually some slides that I give a lot. And I found that they're useful for explaining how to write a benchmark and also how to read the output from writing a benchmark. Because a lot of this is sort of subtle, and once you know how to do it, it will help you immensely. So here is our benchmark. This uses the standard lib benchmark library, and all it does is it just runs. You don't know what this coworker's code is. You just showed up on this project. It got dumped in your lap, and you know that there's some calculate awesome score method that's super slow. That was what you were given. This was in the bug report, so someone has isolated down to at least somewhere underneath that method. Great. So you run that benchmark, and you get this output, right? And that's going to be hard to read, I know, so I'll go ahead and circle what's important. We're going to be looking at that specifically. So running the calculate awesome score took 30 seconds almost, right? That's probably pretty slow for calculating some score, and that's obviously why you got this ticket. So now you're sort of on the right case. You know, okay, this is the thing in question. There is definitely a bug here. But you had 3 times there. And a lot of times people read that rightmost thing and they go like, okay, yeah, 29 seconds, 30 seconds. Okay, that's cool. I'll just go fix it. But the other numbers here are important also, right? So what do these numbers mean? So user is the time spent running code in this process. So that means how long did the actual operating system spend with this current process active, right? System is how much time is spent inside the kernel on behalf of this process. So things like I/O and all that kind of stuff will show up as kernel time because it's fetching from disk or it's getting network packets or whatever it needs to do. The total is just the sum of those, nothing magical there. And then the real is a lapsed wall clock. So it's if you had started a stopwatch when it began and you had waited and then you started the stopwatch again, that would be what this reads. That's the wall clock. The wall clock just meaning literally the clock on the wall. Oops. So we got that. So why does the sum of all the user time and the sum of all the system time not equal the amount of time that we actually spent running this thing? So some of you may have an inkling, and we're going to go through this and figure it out, and then you will see at the end here. Oh, yeah. So now we've profiled it. We know that it's taking 30 seconds. We really don't know why it's this big enigma. So now we need to profile it. And this is where sort of the Rubinius jam really kicks in. So you run Rubinius with this extra flag. Can everybody see this okay? I was hoping this wasn't too small. And everyone, raise your hand if you can't read this okay. Okay, there's people in the back. All right, move forward. So, okay, so you'll run your code and you'll get this output. And this is a report that Rubinius generated of what happened while running this code. And we can see right off the bat that, holy cow, this one thing in our program we spent 99% of it inside that one thing. And additionally, we can look off to the right-hand side and see that it's in some internal Rubinius thing. So you're sort of like, oh, that's a bummer. Maybe it's a Rubinius bug. So you might file this as a Rubinius bug. Hey, this thing, I don't know what it is, but it's super slow, man. You got to fix this crap. And I won't lie, I've gotten that bug before. So we're getting there, right? We interviewed our first witness, and they didn't really tell us a lot, but they told us that something was going on for sure. So we need to dig deeper. So now we run it again, but this time we add another option in here. So this time we ask the profiler to give us a graph of what went on. Not just this single sort of pane view, but a much more detailed view. And this time this is going to be awesome, but it's also a truncated view. So we're going to get entries that look like this, that one, then we're going to get that one. And in this case, we can see, oh, I see. I forgot how my effects worked here. So this is the first one we get, right? So pretend you didn't see that other one. How to read this is, it's subtle but important. So the 16 on the left-hand side there is just saying this is entry number 16. So if we had been looking at this, there would actually be 15 things above it. And then the 99 there is, again, the 99% that we saw earlier. And then all the way on the right-hand side, we see the method in question that we were looking for, which was this channel receive timeout. Whatever that does, it doesn't matter. But this actually will give you a view of all the callers and all the callees involved. And so in this case, we see that actually for all 10 times that this thing was called, it was called from sleep. Okay, well that's interesting. And we can see that sleep was called from, sleep is number 15 on this list. So we would have already seen it, but obviously that spoils the fun. So in this case, we go and we look at number 15, and we see, okay, well, oh, look at this. Okay, so there's this method inside the coworkers code class seems to be calling sleep. Well, I think we may have figured it out, right? What do you think? So we go from sleep to there, and obviously we see that the coworkers code is who is calling this thing. So now we've got a definite place to look. We can go, oh, and we can look in that file, and we can find this. You know who to write the email to, or you know who to go, put it in a headlock or something, right? So now that we've fixed that, we take that line out, we run the whole process over again. This is the whole reason we wrote the benchmark to begin with, so that we have, just like tests, we have something to compare against. So we run it again and we see, oh, great, look, real is now nanoseconds worth of real. So now we know we're totally done. You go home, you know what, you did a great job, go home early today. So, to go back though, why was those two numbers, why was this total not equal to the wall clock time? And that reason was because sleep is invisible in all but the actual real time. So as you're looking at those things, a lot of times if you're adding up those numbers and you're saying, you know what, this doesn't make sense, that those numbers should be much greater than they are, though they should be much closer together. That tells you two things. One, you're being trolled. Someone has put a sleep in your code, which, does happen. Or two, the machine that you're on is actually under high load. And that time, that processor wants to be running much more often than it is, but the OS actually doesn't have the resources to get out of running it. And so that is a good indicator that, okay, this machine itself is overloaded. So you can learn a lot just by comparing those numbers and knowing what you're looking at. So this problem of a method that seems slow, solved. Go home early. So another thing that Rubinius does that's unique to Rubinius is that it can tune your code for you. You don't actually have to go through and figure out all the things about how it works. It can actually do it all on its own. And the reason is that while Ruby is dynamic, it is actually not dynamic all the time. You have the opportunity to be dynamic, but most of the time, you're not. So let's do a quick example. Or as Sandy said, it stucks all the way down. But, okay, my example's next. But the core premise here is that, yes, it's all ducks, but a lot of times they quack the same every single time. Not the greatest joke. Okay, so the audience participation time. You've got this method. Who here would like to guess the class of the local variable str? Anyone want to take a guess? Anyone, please. String. Anyone want to not say string? Okay, no contrarians in the audience. Okay, that's fine. And so, and I'm sure you'd be right. And you'd know that because you are a Ruby programmer, and you'd be looking at, there's a lot of common idioms that we'd use, a lot of cues. One I named str. That's a pretty big one, right? You know that there's a string split method that's going to return an array, and you know array has last on it. There's a lot of cues in here that the programmer will use to figure out how this runs. But to the programmer, but to the computer itself, it doesn't know any of that kind of stuff, right? It doesn't have any of those cues. It doesn't have typing. It doesn't have all that kind of stuff. But what Rubinius can do is it can actually run the code, and it can figure out how the code's being used. So the way I like to explain this feature is to say that every single dot in your code, in your method, or in your Ruby code, there's some functionality there, right? Every time you see that dot, there's something deciding, okay, I got to go find this method called split or whatever. So there's a cache there. And so there's an opportunity there for us to see, okay, let's call this thing a few times and see what happens. And we might call that 10,000 times and see, hey, string, was that 10,000 times? This is an optimization opportunity. And so that's what Rubinius is capable of doing. And sometimes you may think like, well, that's fine, but that's going to be the minority case time. That seems like a kind of a niche bug or niche feature. But the reality is that it's an overwhelming majority. So this is a piece of science, everyone. This is running some code, a very large spec suite. And what this says is that there were, you can add up those numbers. Let's just say 27,000. There were 27,000 dots running this thing. So 27,000 places where a method could be called. Not 27,000 method calls, but 27 actual dots that were run. And of those 27,000, 25,000 of them only ever used one kind of class. And the reason is that Ruby programmers write that previous kind of code all the time. You write it knowing this thing is going to take a string, and you're only ever going to use it with a string. And the vast, vast majority of the code works like that, because if your code was fully dynamic all the time, you would be out of the job, because you couldn't figure the damn thing out. So Rubinius is able to capitalize on that kind of sort of sanity and make your Ruby program go a lot faster. So the crux here is that you should write well refactored code, because Rubinius will actually go through and figure it out for you and make that refactored code faster than if you had put those weird optimization opportunities in there, or a weird hand-optimized code, I should say. So the next thing, how am I doing on time?
23 minutes.
Okay, I'm doing fine. Probably going a little too fast, so. Okay, so one of the other big things was that when we started working on Rubinius, we really wanted to make it for running Ruby applications. We knew that Ruby applications were really where things were going. And I say applications as opposed to scripts, right? You don't see a lot of web applications written in sed, for instance, right? Or awk, for that matter. So really we're looking at the big game. We're looking at, people are going to be writing a lot of code, a lot of big applications. They're going to have a lot of data that they're going to want to manipulate. How can we optimize for those kinds of opportunities? And so certain things inside Rubinius, most things are optimized for that particular case. And a big part of Ruby, obviously, is objects. I mean, everything is an object, right? And so we need to be well optimized for working with objects as much as possible. And Rubinius itself, because we write so much of the system in Ruby, uses a huge amount of objects. So let me give you an example. Rubinius right now uses probably 4 or 5 times the amount of memory when you start it up than MRI. And the reason is that because we load, well, technically an infinite amount of Ruby code more than MRI, since MRI doesn't load any Ruby code when it starts up. But we load something like a few thousand methods and create a few thousand other auxiliary pieces, data structures in order to load. And so we use a lot more memory out of the box. And so we have to be able to manage that memory better and pay that initial debt down over time. Because, like I said, there are lots of objects. So Ryan said something funny earlier. To optimize, I make sure not to create objects. And that is just the saddest statement I have ever heard. So sad. Where is Ryan? He needs a hug. If and when he uses Rubinius, he won't have to worry about that anymore. And I'm going to show you why. So I created a little script that 10 million times it created 100 objects, and it only saved one of them. So there's a garbage to usage ratio of 100 to 1. And this is not uncommon. If you think about, say, accepting some data with like a HTTP post, you might go through and parse it out into different pieces, use some array splits and that kind of thing. To get out just the section that you actually wanted, go through and parse it. You may easily get 100 temporary objects in order to give you that one object that actually makes sense for this particular thing. So given that pattern, how well do things scale for that particular thing? So here, oh, by the way, the code for this particular little experiment is this right here. If anyone wants to, do you want to read it aloud or, okay. All right. Everybody got it who wants to get it? Okay, all right. So this is what the graph of running 187 looks like for this. It's not united at the bottom because it was basically just at intervals, even intervals throughout, and it didn't really make sense for this. But basically what you can see is as you create more objects inside the system, the memory growth grows linearly. And in this particular case, it grew to just over 2 gigs for running this on my laptop. So the question is, how does Rubinius compare with this? Well, Rubinius running the same code looks, oh, no. I put a little teaser slide in there so that I knew to tease my next slide. So again, we've saved 10 billion objects, which seems like a lot. It seems like a lot of data that you're going to be saving around. And additionally, you've created 100, carry the one, 1 billion temporaries in doing this, right? So here's the graph of MRI with Rubinius. Oh, crap. I thought actually when I did this that I had totally screwed it up. And this has happened before, you know, it's science. So you got to rerun it a few times. You got to have somebody check it over, make sure that it looks good. You got to run it a few more times. Sometimes crazy things happen. But as it turns out, it wasn't wrong. So I actually had to zoom it in. So we'll cut it down. We're zooming it in, obviously, to the bottom left. And we'll zoom in a little bit more. So I've labeled it now 100,000 objects, 20,000, you know, that kind of thing. And so what we see is that Rubinius actually starts out way higher, like I said, than MRI. Something in this particular case, it was something like 28 megs or so, right? But then after somewhere between, say, 22,000 objects, they cross. And Rubinius actually stabilizes at about 36 megs. So for that 10 million objects with 1 billion temporaries, the memory growth actually completely flattens out. And I guess I could run it for 100 billion trillion operations, but obviously I had a talk to give. So this particular case is really interesting to me because it shows all the time that we've taken to put into writing a really good garbage collector, a really good memory management scheme has really paid off. Because this is a very common scenario. This is, as people processing more and more data inside Ruby, they're going to start to experience these kinds of issues more and more. And Rubinius can easily show that it is totally the task for tackling this kind of job. Because additionally, if we look at now we've got them stacked up. Right? So the memory versus the time. So additionally, Ruby 1.8 took 530 seconds to run this whole thing, whereas Rubinius only took 57. So Rubinius was, you might expect it to be the flip side, like MRI wasn't managing any memory. It was just plowing through it as fast as possible. Therefore, it'd be super fast. But unfortunately, it's the worst of both cases. And the reason for that is a more complicated, nuanced discussion that if you'd like, you can ask me a question about. But it has to do with the way that we have engineered it to be managing objects and the time and I'm happy to see that all of that time that we put into it has really paid off. So, in other words, don't worry about creating a lot of objects. I got it. So, I'm nearly at the end, and I probably went too fast. So, but what are the next steps for Rubinius? So, more profiling, more tuning. So we get bug reports all the time, and I invite you to try out your code on Rubinius, and where it is slower than 1.8, I invite you to open an issue, and we will fix it. We are sort of getting through things as we get to them, and getting everything fixed up. So there's just the normal run-of-the-mill profiling and tuning to be done. Because we have a huge amount of Ruby code, that's just sort of par for the course. We're also working on a newer, smarter JIT compiler, which can reason even better about that profiling information. Right now, we do a very sort of coarse use of it. We could be using it much smarter, and so we're sort of working on that. We think that that could really take performance even up a notch higher. I'm hoping that we can actually take it sort of into Java range. I think it is totally possible. So, lastly, I'm up here to try and get you to think about Rubinius and think about you using Rubinius. So compatibility is definitely there. I know that in previous years, there's been a lot of talk about, well, I tried my code and it didn't run, I got this weird error or whatever. That has essentially gone away. I very rarely get people reporting that the compatibility of X, Y, and Z gems is no longer, it just isn't there. For the most part, we rarely get these issues anymore. So the compatibility is there. So don't let that, don't rationalize not using Rubinius with that thing. And it isn't terrible for any workload. And this, I'm being honest here. So it's going to be, it'll definitely be slower for certain things. But it will never be just the worst thing you've ever used. But on the flip side, but I've got something to offer for that very mediocre of statements. It is amazing for some workloads. So some workloads, you will be amazed how well it can optimize. And you will never know about how fast your Ruby program could be going unless you actually try it out and try your particular workload, try your particular code inside Rubinius to find out. So what are we going to do when we go home tonight?
Try Rubinius.
That was sad. All right, I'm gonna give you a couple seconds to collect yourselves, and then we're going to try this again. All right, remember, party boat. Party boat. Let's be thinking party boat. Let's try it again. What are we going to do tonight?
Try Rubinius.
There we go. Tears streaming down my face. So, I'll bribe you to try Rubinius. There are stickers in the back. You can buy them. You can buy them? Where did that come from, Evan? You can pick them up. I would be, if I am walking around New York and I run across this old signpost that has a bunch of stickers on it, I see a Rubinius one, oh man, I'm going to be so excited. So, shirts, we have t-shirts. Email us and we will send you a t-shirt. It's as easy as that. So, I see Paul. Paul needs a t-shirt, here we go, buddy. So that is community@rubini.us. I will leave this up because I know a lot of people are interested in free t-shirts. So, everybody got it? Okay. So, one of the things that we're doing right now that Shane has started doing is sort of Rubinius rewards. So, we have a few, sort of like Hilton rewards, right? So, we have a few sort of tiers of rewards, right? The first one is that when you commit to Rubinius, so by the way, committing to Rubinius is as easy as sending in one patch. You therefore are now a committer to Rubinius. We give commit access to everybody who sends in their first patch and would like commit access. So on your first patch, we'll send you a sticker that says, I'm committed. Additionally, at 10, are we doing 10, Shane? Somebody's asleep. At 10 commits, we're doing a special limited edition sticker as well for that. Oh, we're doing t-shirt. We stepped it up. All right. I should have you up here doing this. And something else that we're doing is that if you use Rubinius in production and you let us know and tell us about it, we will be happy to basically write a blog post about you and about your experience and get it promoted and to talk about your particular place and time. So if notoriety is something that you're interested in, maybe that would work out. So that's it. Thank you very much. Okay, we have 11 minutes for questions. Oh, good. Yes.
I would like to try Rubinius in production, and I deploy a lot of apps to EngineYard App Cloud, but Rubinius isn't one of the supported implementations.
So it is in beta. So there is an email address for you to, I believe it is on the UI blog. There's a thing about who to email, and then they will turn on your account. And then you'll be set to Jet. Well, you could, I'm trying not to get him as the bottleneck for this.
Beta@engineYard.com.
Yeah, there you go. Okay. Who's next? Yes. Do I have some examples of things that it is slower for? I mean, I know what it's faster for. I could give example after example after example up here of what it's faster for. What it's slower for is sort of, I know of a few particular cases. So I know that like Marshall right now is particularly slow. It's written, our version of Marshall is written entirely in Ruby. So it can be, that part can be particularly slow in comparison. We don't see a lot of people bottlenecked on Marshall in general, so we haven't really put a lot of time into that particular aspect of it. What we usually get is I'll get someone who will file a bug report saying, hey, you know what, I totally thought Rubinius would be faster with this particular log parsing code, and I'm not sure why it isn't. And we'll go through and we'll see that, oh, there's a weird case in split that in these particular things is actually supposed to shortcut, that we never shortcutted. We were running some long, complicated logic. So there's a lot of those core methods where 1.8, which is implementing these core methods in C, would do some weird, crazy C thing, and that we're implementing them all in Ruby, and so we have to sort of make up the game and make up that difference by doing just hand optimization techniques in there. So I don't have anything specific, but like I said, I would invite you to just run your code and then see where it is. And then I'm happy to basically help people, use the profiler. How do we figure out where the slowness is and how do we get that fixed? I'm happy to. My problem was that I had a backlog of people waiting for me to help them make their code faster, I'd be the happiest guy in America. So who is next? Paul. So the question was, Paul's interested in concurrency, and he wants to know, are we going to do actors or just concurrency library, that kind of thing? The answer is that we don't know yet. We're sort of paving the way for this sort of initial ability to be concurrent. And so we haven't really sorted it out completely how we want to do that. There are facilities that are built into the VM to manage concurrency at sort of the fundamental level, sort of like there are like low-level, very fast spin locks to deal with just what needs to be dealt with. And we have an actor library that's actually in there that Tony Arcieri and Mental Guy wrote many years ago that people have started to use. But we may spin that off into a gem anyway, because it should probably live and be able to evolve on its own. So if you have an opinion, then we'll make it happen. Yeah, this is sort of like, does the JVM have a model for concurrency? Generally, no. It has threads. It has the fundamentals. And so we're sort of right at the edge of the fundamentals to the common libraries stage. So if you're interested, there's a lot to be shaped in that regard. So, okay, yes. So the comment was first that the dispatch library that is in MacRuby, the Grand Central Dispatch Ruby wrapper on top of that would be good to have in other Ruby implementations. I'll answer that question, that comment first. Yeah, Charles and I have talked about that, and I'm 100% in favor. I would love for us to just figure out, like, does that thing need to be in any way implementation specific, right? So it seems like it could just be all Ruby code that runs just that using thread and using mutex and whatever it needs to do, and then we'd be done. It'd be a gem, and people could go out and use it. Paul would have a pony party with it, that kind of thing. So, and then your question was,
how have you found working?
Oh, how have I found it? Sure. So yeah. So the other question was, how have I found working with the lack of atomic operations in Ruby? It actually hasn't been too bad. When I started down this road, I have a tendency to attempt features on dares. And so, this whole branch was actually sort of on a dare. I was like, I'm going to see how far, people say it can't be done. I want to see how far I can get in a week, just basically trying. And I got a lot further than I thought I would. So the upside is that it's tricky, but what I've found is no trickier than it would have been in 1.8, right? So there, things like a plus equals 1 has the opportunity already for there to be a thread switch in the middle of that equation as is. So it never happened in 1.8, and it could happen in MacRuby, JRuby, Rubinius. But for the most part, it would still work fine. So it's sort of a question of going to a less, how do I put this? I thought it'd be worse than it is. I'll leave it at that. All right, yes. So what's the priority of 1.9 compatibility? Top priority? Are we doing 1 to 10 scale or just top?
What's the current status?
So the current status is that Brian Ford, who's the other major guy, has basically been just slogging through it. The big part of it was actually getting the parser all sorted out, because the encoding stuff is actually intertwined with the parser in 1.9, since you can change the encoding of a particular file right there. That's sort of where we are with it. Once that is almost done, he's very close to having sort of the compiler able to be used in 1.9 mode, and then we'll just sort of go hog wild. So I don't believe it's going to take us all that long to get it up to where it needs to be. The preview release was actually going to be out a little earlier, but we've delayed it so that we can have initial 1.9 support in it. So that's kind of where it is. It's imminent. And then getting it fleshed out entirely is sort of the goal before 2.0 comes out, if that makes sense. Any other questions? OK, we'll go over here. So the question was, are we going to inline methods with all this fancy pants profiling information? Yes, we do now.
How deep do you do it now?
OK. It's it's such a technical answer. Oh my gosh. There's a budget that a method has, and it will try to inline as much as it has inside that budget.
Okay.
And if you have any recommendations for that, I would love to hear them, because this is one of those areas in computer science that I don't want to toot my own horn here. I think there's probably only about 20 people who've ever actually implemented it, and all 20 of those people have done it just however they felt like off the top of their head at the time. It is pure black magic. It's not documented anywhere. You have to dig into the bowels of some huge code base in order to begin to understand what it does. So I've just sort of guessed, because there's really nothing else for me to go on. I've written code, I've profiled code, I've seen what works for the code that we've worked with, and then just sort of gone off of that. So it's not a complete guess. It's based on some sort of hand-wavy science. I think was there one more over here? Yes. Yeah, so are there any popular gems that we still have problems with? I would say the two biggest ones are RubyProf and RubyDebug. And the reason is that those two don't run on 1.9 also, because they're so intertwined with the internals of 1.8. So that's sort of those aren't that big a deal, because anyone who's looking to do 1.9 has that exact same issue. So that's not necessarily a Rubinius specific thing. There really aren't any other big ones off the top of my head. Obviously, all the Rails stack works, all the database adapters work, all the most parsing libraries work. The JSON gem was a holdout for a while because the maintainer was hard to get a hold of, and we've gotten since then gotten that all sorted out. So for the most part, we're good to go. So I think we're good. Thank you very much.
Thanks so much, Evan.